All right, guys. So this video is proudly sponsored by the members of our Maison African Motifs. I want to thank those who are part of the membership family for this part and the contribution that you're doing, guys. So as a request that we are supposed to work on the centroids of the laminae, where we are supposed to understand how to work out the center of a certain point that you are given from a certain shape, which is given as the centroids, right? So we are given the first part. I'm just going to go through this as you know, guys. You just need to know each and every part. What is actually that we consider as a lamina? So a lamina is a thin plate that does not have any thickness. All right. Does not have. Is it possible? That is what we have. It does not have any thickness. So it does not exist. All right. Does not have any thickness. So it's actually we can't measure that thing, the thickness of it. That is what they are trying to say there. So because laminas are negligible or of negligible thickness, that is, their thickness can be neglected. It's not, it is not to say they do not have, no. They have, but it is very, very, very small that it can be neglected. So we take their volumes and mass to be zero. The centers of these two-dimensional figures are called centroids, which is the center. The centroids of symmetrical figures are known and are discussed in the subsection that follows. So you work with these ones that are known. You don't form your own centroid in exam. You don't form your own shape. No. You work with the shapes that are already known. They are centroids. So on a diagram, you are supposed to formulate these shapes. All right, what is it that you're supposed to formulate? One, a square. So the centroid, which is our center here, from the y-axis. So we have got the y-axis and the x-axis. So as we are referring from the y-axis, we are going this side. So we'll be talking about the x value. All right. So from the x-axis, we'll be going up. That means you'll be talking about the y value. So at the end, we are referring to this as a point of x bar and y bar. All right. So given A and B, as I say, the x is from the y-axis. So it means at the center here is going to be a half. We are going to have this as a half. Take note, guys. We are from this point going this side. So that is going to be A over 2, this one. X for this side. The same if you are going up like this at the center. So it's going to be half of this. This is represented by what? By A. All right, this we're taking just like a square. Remember, a square, all the sides are what? All the sides are the same. So this will be A over 2. So that's why we have A over 2, A over 2. The same thing that we are having here for the center, for our centroid, for a rectangle, let's say we've got the length and the breadth. The length taken from where? From the y-axis going this side. So from the y-axis, guys, this is your origin. From the y-axis to this point, it is going to be halfway. So this is going to be at the halfway. So that will be L over 2. Also, the B is going to be halfway. As we are going up, the B is this side. So it's going to be halfway from this point. So that will be B over 2. As we are taking this from what? From the x-axis. So that is the idea there. So we are simply saying, or I'm simply saying here that if you are dealing with the x value, which is from the center, which is the center value, we are talking about the distance. This is the distance from the y-axis. From the y-axis. So we shall talk about this if you continue with your netted to N6. In N6, we shall have this into much consideration. There are so many things that we're going to talk about there, about these centroids in our N6. All right. Then if we are talking about the y, this is now the distance. We are now talking about the distance from where? The distance from the x-axis. So it's a distance that you're taking from this point, all right, to this point. From this point to this, it's a distance that you're considering. It's a distance. yet it gives us a point at the end. That distance from the y-axis and the distance from the x-axis together, they give us a point, which is our centroid. So that is the idea there. All right, so you just need to know the shapes. Like I said, do not form your own shape in exam. These are the shapes in your syllabus, and these are the ones that you need to know. Then for a disc, considering a circle, right? Considering given at the origin, it means what is going to be the distance? There's nothing there. So it's just going to be 0, 0. Remember, we need the distance there. So it's already at the center. The circle is already at the center. But you are supposed to consider this for a circle. Let's say there is something like this. We've got a square. Remember, we said we're going to have a square there. All right, how can I put this circle, guys? How can I put this circle so that you understand me? All right, let's say we have got, let me just put it inside. Let me just put it inside like this. So whenever you are to consider something of this nature now, you are going to see that you take this as the distance from this point. From the y-axis, you're going to take this x as this distance here. You're going to consider this distance in between here. From what? From the center. The same thing, if you consider the distance from the x-axis going up to the y, you shall consider this distance, this one. So this will be our x and this will be our y. So you must consider that. This one is taken from the origin. So the center is already at the origin, but this one, the center is not here at the origin. It's not here. But if the center is here at the origin, then it will be 0, 0. But there you consider a distance. We shall see typical questions like that. This is the one they are trying to explain here, that the x is going to be diameter over 2, which is equal to the radius. But it is not a condition of this one. It's not here. It's not on this part. No. We shall talk about that. Then for a half circle, which is a semicircle, we shall have this x. It's already at the origin. Then the center, as we are going from the x-axis, remember I said this is the distance from the x-axis. That one is going to be given as 4r over 3 pi. So this is 4r over 3 pi. That's the formula that we are going to need. All right, then for a triangle, take note. The center given or provided that it's taken from a right-angled triangle, as long it's taken from the right-angled triangle, all right? The distance from the y-axis, meaning to say we are considering the x value, is going to be a third of the base. Taken from, it must be from this. It must be from the 90 degrees. If you are going up again, it must be from the 90 degrees. So it's going to be a third pi, a third h. So at the end, as a center, it's going to be a third b, a third h. But provide this one is the most important. You must have a perpendicular height. You must have a perpendicular height to use this. All right, so we shall talk about that in our questions. All right, then we've got the moment of area, as we talked about this, guys, from our end to the moment of area, that is the force times what? The force times the perpendicular distance. We've got what? The moment of area. So the moment of area of a lamina is the product of the area and the perpendicular distance, that is the perpendicular distance from the axis of what? Of rotation. So meaning to say, if we consider now in terms of area, we are going to see that in each and every part that you are given, you are going to need the area of each section. You're going to need the area of each section. So this is what we have. If we are to consider that we are taking the moments about the y-axis, the moment area about the y, so this is the area moment about the y-axis. So it's going to be the area moment in the y-axis, which is equal to the area times the x, which is representing from our centroid. Remember how we obtain our x. So in this case, you need to calculate this, and you also need to calculate this, depending with the question. So what you're going to do is to make now the subject. So it means x bar is going to be the area moment for y over the area we divide. These are the questions that you'll be asked. The same thing, y bar is going to be the area moment about the y, about the x over the what? Over the area, the total area. Area moment for x over the area. So you will see that these can be separated depending with the question when you're dealing with the area, because we're dealing with the area there. So this is the part that they tried to simplify this for us, to say that this x that we are talking about, to say it is the area. All right, I talked about this, that to say we're going to cover this in N6. So you see, you enjoy that when you're now talking mathematically, we'll be doing this. All right, so we are saying this x bar is equivalent to the area moment about y over the area. Take note, this is the distance from the y-axis. Take note, the distance from the y-axis from. We are from the y-axis going this side. This is the x bar. So from the y-axis, you use the area moment from there. Area moment about the y-axis. This is the one. Over the total area. But take note, the area moment about the y-axis is simply the sum of areas that we obtain when we are multiplying the area to the center about this x now. Remember, we talked about how do you find x? Depending with the shape. You do the same area 2 times x, area 3 times x over the total area. So this is the sum of the areas. We are simply adding what? These areas together. So you can do this mathematically using this formula, or we are going to have a condition. If you understand this, then we're going to have another class where we can tabulate these using a table. It can actually shorten everything. But with this method, you need to have the area for each and also the center, which is the centroid of x. The centroid, we mean to say if it is for y, we're going to need like this. The y value is going to be what? The area moment about x over the total area. So the area moment about x, this one, is simply the sum of the areas that we obtain, area times y, the y values, over the sum of the areas. So what am I trying to say here? Is remember you're talking about this y value, this one, center. So the area is going to be area 1 times y1 and so on. You are going to find these y values each and every section. So it's going to be area 1 times y1 plus area 2 times y2 and so on. Area 2 times y2 and so on over the total area. Area 1 plus area 2 plus and so on and so on and so on and so on, depending with the diagram that you're given. So this is like the traditional way where we are taking these from. But like I said, we can summarize this in a table and we shall talk about that. All right, so the important formula, as we know, guys, your rectangle. Remember our rectangle there, we talked about this in terms of length and breadth. So it's going to be length times breadth. The circle is going to be pi r squared or pi d squared. Then the triangle, half base times perpendicular height, it must be a right-angled triangle. Or if it is like this, we are going to make it to be a right-angled triangle, provided that this is going to be your base and this will be your perpendicular height. That is the concept of a triangle. You take this as the whole base and this as your perpendicular height. All right, let us consider these formulas. I know that there's a lot of confusion right now. Let me explain it this way. Like I said, we are using the traditional method and we're going to come back with these similar questions, but working with an easier way of just tabulating a table and solve. All right, there we are asked in this, I'm just going to minimize this. All right, we are asked in this part to calculate the coordinates of what? The centroid of the laminae in Fig 4.47. The coordinates, meaning to say we are considering both x and y. We are considering both x and y. So in this case, I say that if we are to find the x, let us talk about the x using the traditional method that we talked about. The x value is going to be the area moment about y over the area, total area. that we saw that it is simply remember, if you're talking about the area moment about y, it means we are talking about, this is about y. The distance, we are talking about x bar. This is the distance that you take from the y-axis. You talk of x. So this will be A1 times X1, which is representing what? The centroid of each part. Each section, like in this case, there are two areas that you're going to consider. You're going to have this, a rectangle here, and you're going to have what? A triangle. So there are two shapes there, a rectangle and a triangle. So we're going to have area 1 and area 2. So this area 1 must be considered to the distance that we take from what? From the y-axis. From the y-axis. This is the distance from the y-axis. So it must be distance from the y-axis. From the y-axis. Okay. So meaning to say all these sums of areas must be from the y-axis. Area 2, again, the distance that we're going to take there from the y-axis. So this will be x2 from the y-axis. All right, everything over the total areas is going to be area 1 plus area 2. So like I said, okay, let me finish. Let me finish. I'm going to talk about that later on. So if you consider the part of the x, that is the idea there. All right, let us talk about the y, because there is the coordinates. We need everything. So it means if it was for the y, it was going to be the area moment for the x, it opposes that over the area. So the area moment, talk about y. Which distance is the distance from the x? This one. This is the distance from the x-axis. From the x-axis. So if it is the distance from the x-axis, it means you're talking about the y values. This is your x-axis. From, we are moving from here. So it means we are talking about y. From, moving to where? To the y. So that means we're talking about the y values. So it's going to be area 1 times the distance of the y plus area 2 times the distance of the y, 2. Everything over the total area, area 1 plus area 2. So in a case that there is a shape inside of another shape like this, you subtract that shape. Whenever you find a shape, you have to subtract that shape. All right. I was thinking of having this table in another class. No, I'm going to do it today. I'm going to do it in this class because let us just do and finish. Let us just do this and finish this at once. Okay, this is what I'm trying to say. You have these formulas. So it means that here we are going to need the area 1, the area 2, which is the same here, the area 1, area 2, area 1, area 2, which is the area of the figures that we have shown here. What are the areas that we have? Which figures do we have? There is a rectangle here. This is a rectangle 40 and what? 40 and 20. So area 1 is the area of a rectangle. So in this case, our area 1, because there's no other figure inside of this rectangle. It's just a rectangle only. All right. So our area 1 is going to be the area of a rectangle, which is length times breadth. And length times breadth. This is our length. This is our breadth. So the length there is 40 millimeters times the breadth, 30 millimeters. 40 times 30, what are we going to have? If we multiply 40 and 30, in this case, I was 1,200. That was 1,200 this square millimeters. This is area. Okay, then in this case, we do the same thing. The other part, which is our second area, is the area of a triangle. That's a triangle then. So you're considering a triangle. So how do you calculate the area of a triangle? The area of a triangle, half base times perpendicular. This is your base. This is your perpendicular height. So that will be half of the base times the perpendicular height. Half of the base, which is 50. From this point, remember, this is the whole of this part is what? Is 50. So you are going to consider the 50 there. Half of this 50 times the perpendicular height, which is 30. This is the same distance that we have here. So this is 30, remember, the same distance, same as 40. This is also 40 on this side. All right, so this is 30 that we have. So half of 50 times 30 was going to give us 750 square millimeters. All right. These are the areas. These are the areas. These are the areas. Okay, let's just finish up. Let's talk about the same point, this area 1 here. This area 1 here. What is the coordinate of the centroid? What is the centroid in this case? So we say this is given in terms of x bar, y bar, whereby x bar is the distance from the y-axis, from here, from the y-axis. So from the y-axis, what are we going to consider? It is going to be the length over 2. Remember our rectangle, we said it's length over 2. You still remember these shapes here. Where is that rectangle? I think it's this side. This side. It is going to be length over 2, breadth over 2. This is what you have. So you go back now and check this. All right. So this is going to be length over 2. So meaning to say here, we're going to divide by 2. All right. Length over 2. All right. So sorry for that. So you're going to have the length of 40. It is from the origin to this point as it is. So that is going to be 40 over 2, and 40 over 2 is going to be 20. So that's we've got 20 there. Then we do the same thing for the y. For the y, we are saying the distance from the x. This is the distance from the x-axis. So we are going up. Starting from where? From the origin going up. So this is 30 divided by 2. As you can see, breadth over 2. Remember, it was b over 2. So that's 30 over 2, which is what? Which is 15. All right. That is what you have there. So this is for the first area. All right, guys, I wasn't supposed to remove this. I just need to remove this. All right. Then for the second area, which is for the triangle, we need also to do the same thing. Find our x and our y bar in this case, which is our centroid. So in this case, I want you to see properly what is happening. Truly, we are given, this is the consideration here. I want us to go back here. We were told, all right, I skipped my triangle, this one. We were told truly that this is going to be the third times the base, third times the height. Truly, it's like that. But I want you to consider something. This is taken when it is at 90 degrees. All right, so which is this condition that we have at this point here? We have our 90 degrees here. So this going this side is going to be truly 50 over 3, which is true. This is going to be what? 50 over 3. B over 3. Base times base over 3. The same thing, this h is going to be 30 over 3. As we are going up, it's going to be 30 over, because we are moving from the 90 degrees. But I want you to consider that it must be a condition that we are taking it up from the origin. So the x value now, as we are considering from the y-axis, from the y-axis here, we are moving from this point going this side up to this point of 30 or 50 over 3. So what does it mean? We are going to cover the 40 millimeters, and we cover the b over 3, this one, which is the true part of our triangle. Yes, this one does not change. 50 over 3, base over 3. But are you seeing that there is a 40 over 3, which is there? So this is going to be, a 40 that is already there. So it's a 40 there plus a 50 over 3. So this is going to be the distance from the y-axis, which is our x value. So our x is going to be 40 plus 50 over 3, or a third of what? Or a third of what? A third of 50. And a third of 50, that will give us 56,667. All right, so I just need to extend this part here. So the x value, we saw that is going to be 56,667. All right, what about the y value? The y value, again, it is supposed to be the height over 3, h over 3. And in this case, we are moving from the x-axis. If you take, it's already touching the x-axis. It's already on the x-axis. So there's nothing to be added. If you have to add anything, it's going to be 0 plus because it's already on the x-axis. It's already starting from this one. We have to move a certain distance from the y. We have to move 40 meters. Then we consider the centroid of a triangle. But this one, there's no movement that we have, unless it was a condition like this, where there's another rectangle like this. And maybe this rectangle, it has got 7 or maybe 70 millimeters. You are going to add 70 plus the 30 over 3. But in this case, there's nothing to be added. It's already on the base. It's already on the base, which is already on the x-axis. So that one is just going to be h over 3. So h over 3, which is 30 over 3, and 30 over 3 is going to give us what in this case? All right, this is 30 this side. So all right, guys. So this is going to be 10. So it's just a 10. So that means we have got what? We have got the y there, which is a 10. So everything I think is there. I think we have got everything. I think so. Yes, everything is there that we need in this case. Now follow me, guys, to this point. Follow me so that we finish up. This is it. We calculated two things at the same time. The area of this first part here, we calculated the area and the corresponding centroid of that part. The area of this part and the corresponding centroid for that part. But in this case, the question is, we are supposed to have the coordinates of the centroid. So you'll be asking yourself, what about these ones that we calculate? What are they? No. This one is just a consideration from a shape, the distance that we are taking from them. There we need the overall centroid of everything, the overall, which is this one that is supposed to be taken from this formula. So let us start with the x. So with the x, we are saying that in order for us to have that center value of the x, which is the distance from the y-axis, it is going to be given as a1 times x1, which is the area 1. We have our area 1 here. So it's going to be 1,200 times x1. x1 is the value of x at that point. What is the x? We said our x there is 20. Plus area 2. Our area 2 is what? 750 multiplied to x2 value, which is the x at that point. It's what? We say it is 56,667. So this is what we are having. Everything over what? Over the total area A1 plus A2. That is the total area. Our A1, 1,200 plus A2, which is 750. So by combining this, we are obtaining the x value, which is the distance from the y-axis. And that was going to give us something like 34.103, which is millimeters. All right, you do the same thing on this part for the y. As you can see, we already calculated everything. So we're just inserting our values here. Sorry for that. So meaning to say, for the y value in this case from our formula, it is going to be what? Area 1 times, already the area is, everything is there. But now we are considering the y values. The y value is 15. So it's 1,200 times 15. 1,200 times 15. You do the same thing, A2 times Y2, that is the area 2, our area 2 here, 750, does not change, times the Y value. This time, the Y value, remember, it's X bar, Y bar. So it's the Y value that we need there. So this is over the total area, 1,200 plus 750. So what are we going to have from this part? We are going to obtain this as, if you simplify this, I got something like 13,077 millimeters. So as at the last point is that this must be a point, the coordinate. What is the x value? We obtain the x value as 34.103, and the y value is what? 13.077. So this is the coordinate of what? Of the centroid. So you have to consider this. And also to check your mathematical calculations, each and every part, make sure that you calculate properly. These are some of the mistakes that we are having in our engineering science and for they have got a lot of mistakes from the textbooks, question papers, a lot of things that are that need to be revised. Even from our new edition that we are saying, this is the new edition, we still have mathematical errors that we can't say it's a new edition. So there are so many things that need to be worked on or to be tackled on in this science 4, especially science 4. Other subjects, they are fine. But if you check our science 4, guys, I do not know why is it only science 4. The other subjects, they are totally fine. But science 4, I don't know. All right, no problem, guys. This is it. We just need to work on more questions. Like I said, we can tabulate this. All right, let us go back. We could have tabulated this. I'm just hoping you're going to understand me. I just hope you're going to understand me. All right, so on the tabulation method, this thing does not work. This calculation that we are doing here, I'm just going to ignore this. All right, just going to ignore this, guys. All right. Let's hope you will understand me. So this is, let us just try to tabulate something here. We're just going to try to tabulate something. Let us try to tabulate. So guys, very sorry. I think I'm now delaying and taking your time. Sorry for that, guys. But there's no need to rush, guys. We need to learn, understand this properly. All right, let me just try and tabulate this in form of a sketch. So when you are using a table, all right, when using a table, you can just shorten this. So just using a table, just gonna try to use a table there. All right, so using a table, this is what you are going to need on your table, the properties that are supposed to be on your table. One, you are supposed to figure out the shape. That is the shapes that are there. You're supposed to figure out the shape. All right. You are supposed to figure out the shape that is there. You are supposed to calculate the areas of that shape, the area, which is in square millimeters, depending on the unit that you're given. But specifically, we are given our units in millimeters. So you have to calculate the shape. You have to state the shape there, the area of that shape. Then you are supposed to talk about, to give the x value. And we say the x value is the distance from where? The distance from the y-axis. This is the distance from the y-axis. You are also supposed to talk about the y value, which is from our centroid, which is the distance from where? From the x-axis. The distance from the x-axis. You are also supposed to talk about their corresponding area moment, which is area times the x bar. So you're going to have area times x bar. So area times x bar, if you check from our introduction, this is the area moment about our y. All right. You also need the area times the y value, which is representing the area moment about the x. So this is what you simply need. So you are going to see that with a table, it was going to be nice and easier. And in this case, whatever shape that you see inside of a shape like that, you take its area as a negative. When a shape is found inside, you take its area as a negative. When found on top, there's nothing, you just take as it is. But if it is inside another shape, it is supposed to be a negative because you have to subtract it later on. So you take it as a negative. All right, so if you consider this, we had no shape that was inside. It was just direct and straightforward in this case. So our figure 1, the shape 1 was a rectangle. We had a rectangle there. We calculated the area as we saw, guys. So you're going to calculate the area, length and breadth. You write your area in this case, 1,200. That is the method of this one. All right, then the x bar, we already calculated the x bar. Remember our x bar that we calculated 40/2. So this gave us what? This gave us 20. The y bar, we calculated this 15, which we got from 30/2. It was 30/2. and it is going to give us 15. So this one is just a product, A times X. A, the area, times the X, 1,200 times 20. All right, so if you multiply this 1,000, let me just multiply, guys, 1,200 times 20. But I have a calculator now. This is 2,000, 24,000. 24,000. All right, the same thing, this one and this one is going to be 1,200. 1,200 times what times 15 there. We're going to multiply by 15, which is 18,000. So this will be 18,000. All right. You do the same thing for the second one. All right, you're going to do the same thing for the second one. What do we have for the second one? It's a triangle there. There is a triangle. So you're considering a triangle. How do you calculate the area? This and that. Everything is just a repetition. All right. This can insert a tab, but let me just do this one. So the area there for a triangle, we saw that this is a right-angled triangle, and we used half base times perpendicular height. This everything that you did there, half base times perpendicular height, and you got 750. This is what you got. All right. Then you talk about the x value. For the x value, remember, we said from the perpendicular height, perpendicular here point, it is supposed to be base over 3. But there's a 40, so we added 40 plus 50 over 3 and got this, which was 56. Was it 56, guys? Let us just take our calculator. All right, let me just also try to have my calculator aside. I calculated this before, but you know, guys, 40 plus 50 over 3. That is 50 there over 3. All right. So that is 56, yes, we are actually fine to 3 decimal. Already my calculator, it's already fixed. You can fix this to 3 decimal places. Just press 3 like that. Your answers will be automatically to 3 decimal places. All right. So that is what we exactly have there. All right. I want us to see this. So this is the x value. So we got this from the 40 plus 50 over 3, and this gave us 56,667. All right, you do the same thing for the y value, which is our 10. The y value just said, in this case, is just a third of this. A third of what? 30. 30 over 3. So it was just a third of 30, and that gave us a 10. So you do the same thing, the area times the x value. So you are supposed to find each and every corresponding area, guys. Each and every. So if you multiply this area times x, that will be area here times the x, this one 750 times 56,667, like that. So you are going to obtain something like 42,500,25. All right. You do the same thing. The area times the y value. The y value is 10. So that is going to give us 7,500. All right. So this is what you're going to do from a table. After this, you find the totals, but of the area and the area moments. Remember our formula, it states that. Let me write our formula. All right. Remember our formula as we stated before. It states that the x coordinate is going to be taken from the area moment about y over the a, which is the area moment about y, which is our sum, the sum of ax. Guys, we talked about this, which was the sum of what? The sum of ax over the sum of what? Over the sum of the area. Okay, let us go back. Let us go back where we started. I think we still have this information. Where do we have that part? Where do we have that part? Here, the area moment. Here on this page. Oh, it's actually on this page where I removed it. Here, on top here. You still remember? The x bar, that is the distance that we have for the x, is going to be the area moment for y. That is the sum of this ax, this one, is the one that you are getting from a1, x1, the area times the x at that moment, at that particular moment. The same if it was for the y, it was going to be y is the area moment for x, which is true, over the area. But this area moment for X is the sum of the AY over the sum of the area. So this is what I'm trying to explain here. This is what I'm trying to explain on this part here, down here. Sorry, guys. I'm thinking it's another page. We are still on the same page, just with that we are down here. This is what I'm trying to explain here. So this one is the product that we are having, the area and the what? The X, the area, the X, the area, the X, the area, the X, and so on. So we just need the sum. That is why I'm talking about this sum. The same thing, if we are talking about the Y value, we are going to talk about the area moment about what? The area moment about the X over the area. But that area moment about the X is the sum of area times what? Area times Y over the sum of the areas. So this is the sum of area times Y, which is, we need this one, the product of A and Y, this one. All right, from our information here, we need the sum of this A and X, A and Y, and also the sum of the areas. So you're gonna need the sum, which is the total here. So you're gonna need the summation of the areas. All right, let us just do this. So you're gonna need the summation of the areas on this one. You add this one. 1,200 plus 750. These are the areas that we have. And this was gonna give us 1,950. Remember, this is our area in square millimeters. You do the same thing for our area moment, this one, for the what? A times X, which is the area moment for Y. You add what we got on the first part. This is 24,000 plus 42,500.25. So that was going to give us something like 66,000. 66,500.25. All right. We do the same thing on the last part here. We need the area moment for the what? For the Y. I mean, for the X, which is area, or area times Y, which is the area moment for the X. We add 18,000 plus 75. No, this is 7,500, which was going to give us 25,500. So that is going to be 25,500. This is the area moment, the units here, cubic millimeters, cubic millimeters. But that is not important. That is not even important. That is not even important because you just know it's going to be millimeters. You answer that. All right, so this is what you're going to do now. For the X, it's going to be X bar is equal to what? You consider the sum of AX, which is the area moment for Y, which is this one. This area moment for Y, 66,500.25 over the sum of the areas. This is under the areas, we got 1950. So this is going to be our X bar. 66,500.25. If we divide by 1,950, it was going to give us 34. So this is 34.103 to 3 decimal places. All right. You do the same thing for the Y. That's the idea there. For the Y, you do the same thing. The area moment for the what? For the Y, for the X, which is the product, the sum that we had for AY, this one, which is 25,500. So that was 25,500 in this case. Over what? Over the total area, the sum of the areas does not change. The total area, 1,950. So that's the Y value in that case. All right, so this is 25,500 divided to 1,950, and that was going to give us 13 point something like that, 13.0769, which is 077 to 3 decimal places. That is in millimeters. So as you can see, this is exactly what we had from the previous case. So as a point now, we're going to take the X value, 34.103, the Y value, which is 13.077. These are the coordinates. That is what we have as the coordinate of part of the centroid. Just like that. So if you're given a shape that is subtracting a shape that is adding, that is given inside, The idea there, we just need this step. Everything will be sorted inside of that. Everything will be sorted inside. Everything will be sorted there. So that's the idea. So with these guys, you can, it's an easier part because you just follow step. It's a follow suit. You are just follow, it's just a follow suit. So this one where you now say, take moments about this, take moment about that. Yes, if you understand that, it's one and the same because it's the same thing, area times what? Area times X or area times Y. So it's one and the same thing. All right, so you want to consider another question. And the reason why I do this, I see like a lot of mistakes, like I said. So you see our engineering science guys, I just don't know what is happening. All right, no problem. So very sorry for that. I'll remove this section. All right, very sorry for this. Let's hope we'll be together. Let's hope we will be together. Just gonna remove this one so that it saves us from not losing our important information. So this is it, guys. Let us check this one. Let us just check this one. There we've got a lot of things to consider there. But anyways, so they are saying we are supposed to use, sorry for this. All right. Calculate the coordinates of the centroid of the lamina shown in Fig 4.49, which is there is a wall there with a diameter of 150 millimeters. Take pi to be 3.142. All right, so in exam condition, they won't tell you to use pi as 3.142. You just use the pi that you see on your calculator, that one. So it's the one that I'm just going to do. I'm just going to use that pi. I'm not going to use 3.142 there. All right, but this was an instruction for you guys. You're supposed to use that. But for exam condition, let us just use pi. Pi as it is, pi direct from our calculator. All right. So like I said, if we are to tabulate, we need to understand our diagram. We need to understand our diagram. What do we have? Take every shape, but the shape must be from those ones that are known. The rectangle, the square, the triangle, those ones that are known. We do not know of a trapezium. We never talked of a trapezium. This is a trapezium here. So don't form a shape of your own in exam and say, I'm going to use a trapezium. How? You use those ones that are known, that you know. Unless you know for a trapezium, guys, if you know that one, no problem. All right, so as we saw that, guys, here we're going to talk about what? The shapes. We have got the rectangle, this one, so that we work with those ones that are used, that we are used to. So we have got this rectangle from A to B to D, then from D to C, then to A. Okay, then we have got a circle that is inside a circle, and their distance is already given. This is the distance. This is the distance we already given to the center. Okay, then in this case, we can't use this trapezium. So we have to form shapes that we know. Which shapes? We know of a triangle. So you're going to take this triangle. So you're going to take this triangle here because we know about this. At what? At 90 degrees. Remember, this will be the base over 3. This will be the height over 3. All right, we know about this. All right, then we move on. We are going to take the last one, which is also a rectangle there. We don't know, is it a square, is it a rectangle, but the properties, they are the same. All right, so these are the shapes that we have, meaning to say, but how many shapes? 1, 2, 3, 4 shapes. All right, anyways, no problem. They are so many. But the fact that is inside of a shape like this, it is inside. Once you find a shape inside of another shape like this, that shape carries a negative. You are supposed to subtract that shape. And it is the mistake that I'm seeing in our question paper that the department is not subtracting that. you are supposed to subtract a shape that is inside, all right? You remove that area. From both the area moment, you are supposed to subtract it. So only for you not to forget that, just use a negative. Once you see something inside, whether it's a rectangle like this, and there's a circle inside, or there's another square or another shape inside, whether it's a rectangle, a triangle like this, and there's as long as it is inside, and as we want this part of this one, the one inside has to be removed. It's not on top. Unless if it is on top like this, you don't subtract anything there. If it's on top, you just work as it is. So please do consider that, guys, as you are revising. Do consider that as you are revising. All right, anyways, like I said, in this case, we are going to need to tabulate. We are going to need to tabulate each and every part. All right, so we've got four shapes, 1, 2, 3, 4. All right, so let's consider this. Remember, we said you're going to need the shape. So we're going to need the shape here. Let me just try to reduce so that I also try to have the space to write everything. So we are going to need the shape. This one, why am I writing this bigger? All right, anyways, the area. So you're going to need the shape there. Then you're going to need the area, which is our A. All right. Then what else? We're going to need the X value. The X value, which is the distance from the Y axis. We're going to need the Y value, which is the distance from the X axis. Then our area moment, area times X. Area times what? Area times Y. Okay. So this is what you are going to need in this case. So there we have got a lot of things to consider here. A lot of things, like I said before. So that means let us just do this. So the first shape we are seeing, let us take the wall of this. We're going to take the wall of this, which is A, B, D, up to C, the wall of that rectangle. All right, so that is rectangle. So you consider rectangle A, B, D, and C. This is what we have there. So from this rectangle, it's actually not a rectangle because, okay, let's see. This is 450 this side. This is 200. This is 250. 200 plus 250 is what? It's 450. So this is actually a square. No problem, but you can even write it as a rectangle. So the area there is going to be, remember we said area of a rectangle, it's length times breadth. So that will be 450 times 450. So this one will be 450 times 450. All right, that's 450 squared, or 450 times 450, which was going to give us 202,500 like this. All right, then we move on the X. Remember, X is the distance from where? From the Y-axis. From the Y-axis. And this one is from the X-axis. From. So from the Y-axis, going this side is going to be half. It's a rectangle, guys. We talked about this. We said it's going to be base over 2. So the X value is going to be X over 2. 450 over 2. This side is the wall of this side. It's what? It's 450. So that is 450 divided by 2, which is 225. So this will be 225. The Y value from the center, from the X-axis, from our center going up, as you can see again, the base over 2. Okay, this one was the length, sorry. This is the base now. So this is the breadth. So the breadth over 2, 450 over 2 is going to be 225. There's no change here. Then we multiply area times X value. So we are multiplying there. Take note. Area times this one, our area times the x, this is what we have. Area times x value. This is our area moment for what? For y, as we know, but this is area times x. So if we multiply this, was gonna give us there are a lot of values here, guys. 4, 5, 5, 6. All right, 2, 5, 0, 0, like this. Then for the, as you can see, it's the same also for the y. So this will be 4, 5, 5, 6, 2, 5, 0, 0. All right, 3, 6, 8 values. All right, so this is our area moments there. All right, so that was the first shape. Let us move on to the second one. So guys, you just have to be careful, all right? You just have to be careful there. Let us consider the second one. For the second one, we can consider a circle, depending with which shape do you want to use. So as for me, I'm just gonna consider a circle. This one, a circle. So we have got a circle there. All right, that's a circle. All right. So for a circle, we need the area. Remember the area of a circle, pi d squared or pi r squared. Since we are given the diameter already, let us just use pi d squared. So that will be pi times d, 150 squared over 2. That is the area of a circle there, pi d squared over 2. So this will give us 5,625 pi, or as a decimal, it's 17671.459. Okay, that's it. No problem. We are together, guys. Let's just be, yeah, we will get there. We'll get there. Let's move on to another one. There we have got in this case the x value. Like I said, here we're gonna need the x value, which is from the y-axis. So from the y-axis, we are just considering this whole distance here. We are already given here the distance to the radius, to the center, to the center from the y-axis. This is the distance exactly as it is of what? 220. There we already have this 220. Then from the x-axis, as you are going up to the center, we are already given the distance there. It corresponds to what? 200 millimeters. So there we already given the distance 200. All right, so there we just need the products there. So this one is just, you just have to be like patient enough. All right, guys, I'm just gonna see here, what are we getting? 220. Well, let me just show you the calculator. No, this is 388 7720 comma 98. You see, if I show this calculator, anything can just pop out from the screen, guys, and you see a lot of things there that are not necessary for you. So that's why I just avoid this, but just gonna turn off the notifications. I think that's the best. And this was gonna give us something like this. All right, so there we have got all right, so like I said, that if we are dealing with a circle, I'm actually saying something. I'm actually using the same thing that I was saying you must avoid. I said whenever you're dealing with something that is inside of a shape, just work out with a negative so that later on you don't have problems. So this area, just use it as a negative there, because it is inside of the circle. Yes, you know that you're going to subtract, but just put a negative so that you won't have a problem. So it is the same thing. It is going to affect here. This will be a negative. It is going to affect here. This will be a negative. Remember, negative, positive is going to be a negative. So that you won't have challenges later on when you are now calculating. You forget that it was supposed to be subtracted. No. So avoid that. All right. So it was actually something that I said, and I was, okay, no problem. Let's do the third one. The third one, what do we have? The third one, we can consider this rectangle here. We've got a rectangle there, which is from H to F to E and back to D like this. There's a rectangle there. All right, so this one, the area of a rectangle does not change, length times the breadth. So this is our length and this is the breadth. So this one, what is the distance? It is the same distance as this one. No. We have to calculate this one. It's not 200. We have to calculate this, but it's an advantage because remember we said the whole of this line before it's what? It's 450. And from here to here is 300. From here to here is 300. So it's going to be 450 minus 300. 450 minus 300, we remain with this one. So 450 minus 300 is going to be 150. So this is 150. Then this one, this side here, it corresponds with this one. It's already taken here. It's 150. This one, 150 millimeters. So it is the same 150 here. It is the same 150 here. So the area, length times width is actually a square. They are the same there, 150 times 150. So this one was going to be length times breadth, which is 150 times 150. So 150 times 150, that was going to give us 22,500. 22,500. All right, square millimeters. Remember, the unit does not change. Square millimeters, cubic millimeters here. So we move on again. We have to calculate the x value from the y-axis. From the y-axis, this one. For the rectangle, guys, we're just going to take as it is. Take note. From the y-axis here, we are moving straight. We're going to cover this distance first. So meaning to say, we are going to cover the 450 millimeters, this one, this distance. But remember, for a rectangle, we said the centroid is given as L over 2. So that's going to be plus L over 2. The length there, which is what? 150. So it's going to be 450 plus 150 over 2. You have to cover the distance there taken. So 450 plus 150 over 2 was going to give us 500. So the x value there is 500. There we have got bigger values, guys. All right, let's do the same for the y. As we are going up for the y, is it being affected? No. The y is not even affected because, as we can see, the y is from the x-axis going up. So it's from the x-axis going up. There's nothing affected there from the x-axis going up. Y, take note, guys, this is our x-axis. We are just taking going up. We do not have any other shape. We do not have any other distance moved. So we're just going to take this as the breadth over 2. So the breadth is what? This distance, we said it's 150. So that's breadth over 2 there, which is 150 over 2, which is what? 75. So this was going to be 75. I hope, guys, you're taking also the calculations that I'm showing there aside. They are very, very important. They are very, very important. All right. This one was not 500. This was going to be 525, guys. Why am I taking this? Remember, I said 450 plus 150 over. This was 300. 300. Why am I taking the 150 there, guys? All right. I'm actually taking a lot of things into consideration here. I need this 150 over this one. 450 plus 150 over 2. Yes, it was 150 over 2. This was going to be 525. 525. So 450 plus 150 over 2. Yeah, 525. So let us just correct this one, guys. All right. Okay, so that we have calculated this, what is needed now? As before, we are going to need the area moments. For the corresponding area times the values that we are given. Guys, we have a lot of things now. Area times the x, this is area times x, so you're going to multiply this 22,500 times 525. Guys, there we have got a big value there, 1,181,2500. This is what we have there. Okay. Then if we multiply by 75, it's going to be 1687500. This is what you're going to have there. Are we still together? I just hope, guys, we are still together here. As you can see, we've got a lot of things. Now, the last part is, there is another shape here. The last one, you see, there is a triangle there, which is BFH. Triangle BFH. So we've got the last shape there. All right. So we have got the fourth, which is triangle BF to H. So the area, you do the same thing. The area of a triangle, guys, does not change. Half base times perpendicular, because we put the base there, and the perpendicular height. But are we seeing the height and the base there? Are we having them? Are we having them? Area is half base times perpendicular height. The base we have, this one we said is 150. So it's half of 150 times the height, this one. This one is this one, the 300. So you're going to multiply to 300. So that was going to give us, again, 22,500. All right, they are obtaining the same area as that one for, okay, no problem. So the area there was going to be half BH, half of, we said 150 times 300, which gave us 22,500. All right. Then what about the X value, the distance from the Y axis? The X value, the distance from the Y axis. So from the Y axis here, the distance we are going to move first, this one up to this point. We are going to move 450 millimeters first, this one. This is the one until we reach the triangle. From the y-axis, there's 450. Then plus b over 3. Remember, we said it's base over 3 for a right. From the right, as long as you're moving from the right angle, it's b over 3. From the right angle up, h over 3. So this one was going to be base over 3. Our base there is what? 150. So this is 150 over what? 150 over 3. And this is going to give us 500. So this was the one that's going to give us 500. This one. I was just mixing my answers there. So this is 500. You do the same thing for the y. For the y, we are moving from, this is the distance from what? From the x-axis. As we are moving from the x-axis going up, we're going to cover first this distance, this one going up. We are covering this 150 first as we are going up. We are going to cover 150 first. Then we consider from the perpendicular going up, this one is h over 3, so it's 300 over 3. So consider this. Go back and revise each and every part that you're given on our Centroids, guys. Revise each and every part. But also now you have to make adjustments on the questions. It's not like every question you're just going to use h over 3, b over 3. No, there are adjustments to be made. Is it connected on top of another shape? Is there a distance moved first? You move first the distance, then you apply the centroid concept. The centroid concept, it comes after the distance that is on the diagram has been moved first. So that is the idea there. All right, so very sorry for that, guys. So this one is just a sketch, guys. So there we're going to consider the sum, the product here, area again. Our area, 22,500 is going to be multiplied to 500. And that is going to give us 1. So there is a lot here, guys. 1, 1, 2, 5. There are 4 zeros there. 1, 2, 3, 4. All right, the same thing if we multiply to 250, it was gonna give us 5, 6. All right, 5,625,000. Yes, there are 3 zeros there. So that is it. So just like the previous case, if you are having a table like this, it makes things easier, and even your work is smart, because here you're just adding everything we have. So we are now combining everything. These are the sum. The sum for the area, the sum for the area moments are the ones that are important. So in terms of the areas, this is going to be this one. Then when you are adding, remember for a circle, it's a minus. Why? It's inside of what? It is inside of a certain shape. So this one, you have to subtract it. We have to subtract that type of when you are given that type of a question when it is inside of a shape. All right. So let me just try to bring my calculator here. All right. So let us add. We have got 202. This is 202500. All right. 20250 plus. How many zeros there? 2 zeros only. Sorry for that. These are just 2 zeros there. Plus, this one is a negative, so you're just gonna subtract it. Gonna subtract 17671, comma 459. All right. Plus this one we add 22500. Plus we also add this one 22500. 22500. All right, so that's it. We're gonna get these guys. That's a big value that we are obtaining. But anyways, you just have to write your values as they are. As they are. All right, so this was gonna give us, okay, let me just try and have it here. Okay. And the best thing that I'm just hoping this is not gonna affect my class. I'm just gonna be able to finish, guys, because there are a lot of things that I've written here, and these softwares, they tend to misbehave. It was 28. It was 229828, comma 541. All right, you do the same thing here. You add these ones, all these ones, guys, that we are given there. That is gonna be what? Let us add and finish up. So guys, this is an introduction. Just also try to bear with me. Just also try to bear with me here. So these are the ones that we are adding. 4, 5, 5, 6, 2, 5, 6, 2, 5, 0, 0. 3 is 2 zeros only. Minus this one. Remember, it is a negative 3, 8, 8, 7, 7, 2, 0, comma 9, 8. Okay. Plus this one, which is 1, 1, 8, 1, 2, 5, 0, 0, plus this one, which is 1, 1, 2, 5, sorry, 2, 5. How many zeros? 4 zeros there. They are 4 zeros. So this was gonna give us this whole value that we are seeing there. So as we can see, it was a whole lot of things to be considered there. I just hope we are obtaining the same answers also. So this was going to be 6. Okay, let me just try and have some space here because we're not gonna win here. Just know this is for the sum of this one, all right? So this was gonna be 6, 4, 7, 3, 7, 2, 7, 9, comma 0, 2. All right, you do the same thing on this other hand. On this other hand here. All right, let me just store them. Shift store this one at A. All right, so this one, I stored this at A in case I'm gonna need this. I'm gonna recall that. All right, let us move on to the other one. I just hope I shared the screen there so that you can see. All right, you add again. So my answer here is already at A. So I just have to add the other one, 4. All right, my calculator, why are you not corresponding? All right, guys, I just need this one. Very sorry for that. Just gonna need back my calculator. So you see, guys, when we are saying subscribe, this is what we try to mean. You have to subscribe. What we go through is a lot. It's a lot. So that is saving these things. They'll be saving. So they just pretend. They just tend to misbehave. Anyways, this is 4,562 point. No, there's no point there. This is 500 there. Plus this one is a negative. So this is going to be minus. Remember that circle. 3534291.8. All right, plus 1687500. This software will humble me. I know. Even the way that I'm too fast now, I can't be that too fast now. All right, anyways, this is it. So you were going to obtain this value, and I'm gonna also store it so that we have got the same thing, just like the previous case. But I just hope you see it. Just hope you saw it. All right, so this is it. Let us just store this one at B. So our answer for this is gonna be taken from B. All right, so that is the idea of the question there, which is we got something like 4. No, it was 4,934,0708.20. All right, 0.20, which is okay, fine like that. All right, now that we have these, remember the consideration or the concept or the idea there, it was for us to have the corresponding area moments. The corresponding area moments in that case. So with these area moments that we obtained, we are going to combine them now. So in this case, guys, also check your values if our values there are fine, because we're using a lot of values there. So the X value, we said, is going to be taken from the area moment of the Y, which is the area moment of Y over. So this is just supposed to be the area moment for Y over the total area. So the area moment for Y is this product of AX, the product of AX, this one, the product of AX, which is this value. So remember, I said we are going to store this at B. So it's just gonna at A. So it's gonna be 647,372,79.02, something like that, over 2298 28.5. Oh, wow. Okay, guys, let us just use our calculators and see. Already I shared the screen here. All right. So that is the answer that we had at A. So it's going to be RICO A. This one as it is, as you can see. But we're just going to divide by 9829,541. Like this. So this will give us 281. All right, 281,6, something like that. So guys, you also check your values if we are together in terms of our calculation, but this was going to be 281,675 millimeters. All right, so we remember we are dealing with the bigger values, so the rounding off, we are not going to get exactly what we are supposed to be having, like, guys. And also the area of a circle, I used the pi as it is there. But remember, they said you're supposed to use 3.14. So according to this, these are the values that you're going to have. So now let us consider for the one for the Y. So for the Y is going to be, again, the area moment of X over the area this, which is simply the sum. This one is the sum of area times the Y values that we're talking about over the sum of the area. So we got this one, which is this one. So thus is going to be 4,934,070.8, everything over the sum of the areas, which is 229828,541. That's all. Yeah, that is it. So it's a RICO A this time. All right, we need that answer at B this time. It is at B, this one. Remember, we stored this at B. So you're going to say RICO B divided to this as it is 22 9828.541. So that was going to give us 214. All right, so this is 214 point something like that. All right, so that is a y coordinate is going to be 214 comma this is 685 millimeters. So with these guys, we are done. We just need to combine now. This is a point. So the we are considering as a point. So questions under exempt condition, they are going to specify. They are going to specify what is it that you are considering. Is it the x or is it the y? Right? If they talk about the distance from the y-axis, you are considering x. The distance from the x-axis, you are considering y. What is it that you are asked? Or maybe they just asked you to calculate the coordinates of the centroid. If it is like that, you have to calculate both x and y. So in this case, our x, we said, is going to be 281.67. And this answers is just something else. As we are considering the working there, are you seeing how you're supposed to work with it? Are you seeing the idea of the question? So this is what you're supposed to do. This is what you were supposed to have in this platform, in this part. So you have to consider the shape there that you are given. So I want us to check an exam question. Now, this is just an example, like an example, how is supposed to. So I want us to check an exam question and see how do they ask now, like these typical questions. So guys, with this form of a table that you can see here, with this form of a table that you can see, we can see that it saves us a lot of time, So there we have got a similar, very, very similar question to this one, but it's a past exam paper that we have. This is an exam typical question. All right, there we were given study diagram 2 below to determine the position of the distance of the lamina from AB, take note, from AB. Meaning to say we are talking from the x-axis. A, B lies in the x-axis. So which distance are you talking about? It is the y distance. So we are supposed to calculate y there, not x, but we are focusing on the y value. Take note. And we are given the wall in the triangle, yes, a diameter of 20 millimeters. So there is a hole inside here, having a diameter of what? Of 20 millimeters. So this is 20 millimeters. And hint, we are given h is equal to 77.942. So in actual sense, if you were not given this, you were supposed to calculate this h. From which concept? Because we need the perpendicular height. Remember, when dealing with a triangle, we're going to need the perpendicular height. So to calculate this h, we were supposed to use the Pythagoras theorem because this is a right angle triangle here. But already you are given, but this is what you're supposed to, if you're not given, because you can find another question that you're not given. There you have to find the h. The hypotenuse squared is equal to a squared plus b squared. That is our hypotenuse, is 90. 90 squared is equal to a squared. You're going to consider 45 squared plus b squared, which is the height squared. So that's 90 squared minus 45 squared is equal to h squared. So to find our h, all right, the h is the height, not the hypotenuse, but the height. All right, let me just use b because I might end up confusing someone here. Let me just continue with my b squared. So that means our b is going to be the square root of this, the square root of 90 squared minus 45 squared. That is going to be the b, which is the simplification from your calculator is going to give you something like 77.94228.634, which is exactly this one to 3 decimal places. So you were supposed to actually have calculated this. But in this case, they gave you this. So you are not to calculate this. No, you are not to calculate this. They already gave us. So we are simply going to calculate, remember we need the y value, and we say that before the y value is supposed to be taken from the area moment about the x over the total area. So where do we obtain that from? Using our diagram, we simply need the areas. We need the areas. In this case, we're talking about what? The centroid. So you're going to need the area and the area moment. So like I said, we can draw our diagram in this case, guys. Just pardon me for this sketch. It's just a sketch here. So you're going to need the shape. All right. Then we're going to need the area. Then we say there we need the X. Well, since here we are considering the Y, meaning to say we are going to need the area moment about the X. And the area moment about the X is the one that is taken from the X. So we are considering about the Y values. So we're not going to need the X values. We are only going to need the Y values, which is, I said, this is the distance from the X, the distance from the X-axis. Remember this concept. And also, we are going to need the product of the area and what? And the distance from the X-axis, which is our centroid. So that's going to be the product, which represent what? The area moment about the X-axis. The sum of it. So you're going to need the sum of these values that we have here. All right, no problem. So let us just try to have a sketch, guys. Like I said, this is just a sketch, guys. Don't consider to say this, that. This is just a sketch. I just hope you are following, even though this is not smart enough, but I just hope you're following that. So the first shape that we have, we are considering a triangle, the wall of this triangle. Let's say this is A, B, let's say this is C, and let's say this is D. All right, just gonna consider triangle ABC. So I've got a triangle, and we need the area of a triangle in that case. So what is the area of a triangle? From the base, half base times perpendicular height, we have the area of this triangle. All right, so this is gonna be half base times perpendicular height. So we know that this is half base times perpendicular height. So it's simply half of the base of the triangle, which is 45. So this is half of 45 times the perpendicular height. Remember, it's the one that we were given. We did not calculate this, we just given. But if you, like I said, we were supposed to calculate this 77.942. So you're going to take this as it is. 77.942 like this. All right. So this is half. Guys, why am I taking? I'm already calculated the half already here. This is all right. 177 times here. So this is half of the base. We are taking the base. This is our base, the base of the triangle as it is. Remember, this is our base. So the 45 is already the half. All right, the 45 is already the half. We want the base as it is, the 90 there. So this is half of 90. Half of 90. Sorry for that, guys. So you are going to obtain the area of the given triangle. Remember our area in square millimeters. These are millimeters. So that was going to be 3,507,39 in square millimeters. Then the distance now from the x-axis, which is our y bar in this case, from the x-axis, remember where we are considering from the x-axis. So from the x-axis, considering the y values going up, we have a triangle and we are moving from a 90 degrees. I said as long we have got a triangle and we are moving from a 90 degrees, this distance for the y value is going to be taken as h over 3, a third of what? Of h. So the y value there is going to be h over 3, and that is 77.942 divided by 3. All right, so that was going to give us h, which is 25,981. Then the area moment is the product of area times the y value there. You have to consider the product of the two. All right, so you have to be careful on this part. Very sorry for that, guys. All right, so there you have to be very, very careful. Just multiply the area and this one. You already have these ones. All right, so I'm not going to rewrite this. I'm just going to write the answer. That's 91125,500 and so on. So you have got your area moment there. You do the same thing. All right, let's consider another shape. So if we see this shape here, it's inside of another shape. The circle is inside. I told you guys, whenever the shape is inside like this, you subtract it. So you take that to be a negative. This is going to be taken to be a negative. So we're told that the diameter of this shape is given. All right, we are told the diameter is 20 millimeters. So the area, remember, from our pi d squared. So the second shape from a circle, we're going to have our area from pi d squared. So that's pi times the diameter, 20 squared over 4. You are going to obtain an area of 100 pi, which is negative 314,159. Remember, the negative there is that it is inside of another shape, so you have to subtract it at the end. So if you know that you're going to subtract, no need for you to write the negative. But if you're someone who knows that you forget, just put a negative there. All right, then the y value for a circle, as we know that if you're dealing with a circle, you need the distance up to the what? Up to the center. So from the y value here, we just need to move the distance up to the what? Up to the center of the circle. So what does it mean? Up to the center of a circle, we are going to move one. We are going to move this distance, this one, which is what? 45 millimeters. So we have got 45 millimeters up to the circle. Then from the circle up to the, we are supposed to move up to the center of the circle. So if the diameter of the circle is 20 millimeters, so what does it mean? The radius is going to be over 2. Divide this by 2, you've got the radius 10 millimeters. So meaning to say the distance of y taken from the x-axis going up to the center, you move up to when you get to the center of the circle. Take note. So it's going to be 45 plus 10, which is 55. So this is simply 45 plus 10, which is going to be 55. Then we need the product, this one and this one, so it's going to be a negative 17,278,745. So that was the idea there. These are the only two shapes that we have. So with these two shapes, we are done. We just need to combine everything in this case so that we determine the distance there. So what are you going to need? Like I said before, we are going to need the total here and also the total of the area moment. These are the only two things that are important. So what is going to be your total, which is the sum? For the area, we add, but as you can see, it's a negative, so it's going to be this one minus this one. We add to a negative, so it's going to be subtraction because it is inside of what? Inside of the shape. That is why we have to subtract this. So this was going to give us 3193,231 square millimeters, our area moment in cubic millimeters. If you combine this plus this, take note there's a negative. So it's going to be this one minus this one, which is going to be 73,846,755. So that's it. With this, guys, we can obtain the y value, which is the distance from the x-axis. That is the area moment about the x over the total area that we had. The total moment, area moment about x is the product of a times y over the area. This is the sum. So we got the sum in this case, 73,846.755, everything over the what? The total area. If you're considering area, your area there is 3,193.231. So thus we have got the y value, just like that. So this is how your questions are going to be given. So you're going to obtain 23,126 millimeters. As we can see, these are cubic millimeters. These are square millimeters. So cancel, that will be millimeters at the end. So I would like you guys to revise as much questions as you can so that you'll be able to grasp the whole concept before we talk about the center of gravity. This is the centroid. Then we're going to have the center of gravity when we are dealing with the volume So whenever we are dealing with the centroid, guys, as long we are dealing with the distance of the lamina, which is at the end, you'll be dealing with the coordinates of the centroid. You must be talking of the area and the area moment. The area and the area moment. We shall talk about the other one, which is referred to as the center of gravity. The center of gravity, there you must think of the volume and the volume moment. So we shall talk about that. So more to come from Meson African Motives till we meet again.